This is a continuation of the video Rocks 9b.3, part 2. We're going to talk now about mining, and I'm going to show you quite a few slides with pictures, and some of them have a lot of text because they're describing what you're seeing in the pictures. But I'm going to give you the overview of each of these sections here on this outline. So we're going to start with the exploration topic, and basically exploration involves what the geologists do, which is mapping an area, possibly imaging the subsurface, looking for ore deposits, sampling the surface, maybe sampling the subsurface, and doing some chemical analyses. So those are the main parts of the exploratory part of mining. But let's look in a little more detail. So ores need to be located, which is the exploration part we're going to start with, obtained, which is the extraction part, and then they need to be concentrated, and this is called beneficiation and involves things such as smelting and refining, and these pictures are each showing different parts. It's not done there though. There also has to be some follow-up, such as remediation and reclamation, to make sure that the mine closes safely when the operations are done. So back to exploration. You've already seen some of these slides when you did your review for your project number 2, where you looked into one of these sites that was not closed properly. So mining is very expensive, and it takes a lot of time, takes a lot of resources, people, so you don't want to just haphazardly start digging away for a resource. You want to make sure that where you start your extraction is the right place. So you need to determine the location, the size, the depth, the orientation of the deposit. Here's the land surface, and you can walk on the land, and let's say you see an outcrop of an ore. Well, you can see where it is on the surface, but how do you know what it looks like below the surface? What direction does it go? It might go like that, right? It could be this long, linear shape of a body of ore. Or it might be even larger and have some sort of fold associated with it, and where the kink of that fold is, you happen to be seeing it outcrop at the surface. On the other hand, it might even be a very small deposit, and you happen to be seeing the top of it, but it might not go very far below the surface. So as I said, geologists use a combination of techniques to try to understand the size and extent of the deposit they're interested in. So they use maps, and here is a geologic map, which of course I don't have time to explain, but we do use a lot of maps, and we also do something which is called cross-sectional maps, where we take slices through the earth and we look at them in cross-section. And I've done some cartoons in class where we've looked at slices of the earth in side view. These are done very carefully down here with a lot of knowledge of the way things are dipping at the surface to make projections of what we think happens at the subsurface. We also do site visits. We go out in the field, we might do chemical analyses to see what kinds of elements are in the soils, etc., to try to figure out if what we're looking for is in the area. Here's another little set of things we can do. We can use non-invasive techniques to study depth. Remember how P and S waves from earthquakes can help us understand what's inside the earth. Well, we can use that same idea to understand the depth in the shallower regions by using seismic waves. And there's a little video that I usually show my students. Actually, it's an animation. You should check it out. And it shows you how we can use seismic imaging to understand the shape and size of an ore body just below the surface. So here is an example of a setup where they are setting up sort of like a large hammer that makes a pounding sound on the ground, and that's recorded by some seismometers, and then they can get an image of what's down below the surface. They can also drill down into the surface and extract cores of rock to see what's down there. Okay, so once we've explored and we've decided this is where we're going to extract our ore, we have to do extraction. There are two main processes that are used for extraction: surface mining and underground mining. So let's look at each. This usually happens after years of study to decide where to set up your facility. Surface mining is sometimes called pit mining or strip mining or mountaintop mining. Here are some pictures of surface mining. And then underground mining, sometimes called shaft mining, is, as it sounds, underground. And here's a picture of an underground mine. Surface mines are some of the largest mines on Earth, and here is Bingham Copper Mine, which I showed you in the last video, and surface mines produce the largest amount of material. they can produce up to 150,000 tons of ore a day. Now I put that in red because I want you to hold that number in your mind. 150,000 tons a day. And here's another example of a surface mine, and there's people circled down there to give you a sense of scale. And of course there's heavy machinery involved and a lot of blasting to break up the rock. This often causes significant damage to the surface of the land. It's not real pretty, and you have a lot of waste rock, which is the rock that's not useful. It doesn't contain the concentration of ore that you want. I highly recommend you check out this video. I often show it to my students in class. It's the world's largest recorded mining blast, and it's a little bit fuzzy, but it's kind of fun. I recommend you check it out. Underground mining uses tunnels and vertical shafts, and these are much smaller operations. These might end up generating 100 to 1,000,000 tons of ore over the entire lifetime of the mine. Now that's 1,000,000 tons over the lifetime compared to 150,000 tons per day of the open pit mines. So you can see there's a huge difference. The land disturbance when it comes to underground mining is much less. You have much less waste rock. In fact, you can take that waste rock and you can backfill areas that you've already gone through and extracted what you wanted. Byproducts of extraction include waste rock, which I've mentioned a couple times. And the problem with waste rock is that it's exposed to the elements, and water can come through and chemically leach out byproducts from those rocks that contain sulfate minerals and can lead to acidic conditions in groundwater. And the US unfortunately has a legacy of having very hazardous mine waste rocks where mines were not closed properly. In addition to searching for areas where there's a significant concentration of what we're looking for, there are a number of other factors that influence where you're going to set up your mine. I mentioned looking for where the mineral exists, but you also want to have a high concentration of it. You want to have a high grade of ore. You don't want it to be too deep. You want to have the technology available to make it economically possible. You don't want to have a large environmental impact. You need to have transportation and water available. What if this is in the middle of nowhere? You might have to build roads. You might have to bring in the water. There are regulations to consider, politics, social norms, and human health concerns. And here's an example of people who are protesting the possibility of a mine being developed in their neighborhood. Beneficiation is the part where we've got the ore. Now we want to extract what we really want, the metallic mineral that we're after. And this involves crushing and grinding and smelting and all those materials that separate the ore part of the rock that we want from the part we don't want. So beneficiation is going to take something like this, which has gold in it. You can see the gold, but this is ore because there's a lot of other stuff. And we want to turn it into an ingot, for example. This is an aluminum ingot, a gold ingot. So beneficiation is the process through which the desired mineral is concentrated. And in many cases, certain ores contain more than one type of mineral. Sometimes silver and gold occur together, and so you can get more than one mineral at a time. So basically the rocks are crushed to smaller and smaller bits through various kinds of processes, and then they are milled, which means that they are actually crushed into a fine powder. I particularly like this picture because it shows a cell phone case for scale. Eventually this stuff is mixed with water into a slurry, and there are some very clever flotation processes that can actually use the bubbles to grab what you want, and they float up and you can skim off the metal you want. Very interesting. Another great video that's only 5 minutes long to watch is listed here. And then smelting is when you heat the material up and you get the material that you want, sinks to the bottom of the melt, and the other stuff that you don't want floats off and it gets removed. Now, byproducts of beneficiation include tailings. And tailings are the slurry, all the sludge that you made while you were doing all of the milling and separating that aren't the material that you want. And so what happens to that? Well, a lot of it just gets poured in what's called tailing ponds. And here's a picture of some very large tailing ponds at a mining operation. And these can be thousands of acres, and they can provide a lot of problem for the environment, in particular something called acid mine drainage, which is when the waters that are in this material, in the tailings, can be laden with copper or iron or other things that we don't want in our groundwater, Here's a copper later tailings water that's evaporating and leaving copper behind. Here is some dried out tailings, and now that's become windblown and it's contaminating the air. So there are a lot of problems that can occur from the byproducts of beneficiation. So the last part here is reclamation. When your mine closes, we want to make everything look nice again. But first, we want you to clean it up, and that's remediation. So the mine closes because maybe you've run out of the material you want, or it's no longer economically feasible to keep getting the mineral because now it's deeper and you don't have the technology to get it. And so mines close. Sometimes they fill with water if they're underground, but you always have to make sure you clean it up. So reclamation, as I mentioned, is the making it look natural again part. And so here are some various examples of piles of tailings and things like that that were treated and made to look natural by having plants grow on them again. This one is kind of funny because it's a large wall of rock, of waste rock, that if you didn't look twice, you might just think is natural, but it's not at all natural. Remediation is where you have to go in and fix the environmental problems that you caused. And so acid mine drainage is really one of the more common problems, and they have to go and treat that acid mine drainage with other chemicals that can counteract the acidity of the water and make sure these problems are taken care of before they actually leave the site. So luckily in the 1960s and 70s, the US passed several different kinds of federal regulations to protect the environment. Unfortunately, as you have seen, depending on which topic you chose for Project 2, many mines that closed before these acts passed are just sitting there dirty and need to be cleaned up.